And now you can start visualizing the beam on the preview. This tells the trace to ignore the character that is firing the weapon. Here's our character, and there you can see. When you are building a shooter in Unreal Engine and you are not using a physical projectile, you still need a strong way to communicate the bullet's trajectory to the player. That's where visual feedback becomes critical, and one of the most effective techniques is using a fast responsive beam or a tracer effect. In this video, we're going to build that effect step by step. It is not a physical bullet. Instead, we're using a Hitscan approach with line tracing, which we covered in the previous lesson, and layering a visual beam on top to clearly show direction, impact, and responsiveness for the player. We'll create this effect using the Niagara system in Unreal Engine 5.7, setting up a ribbon-based beam that starts at the weapon's muzzle and ends at the hit location. Then we'll move into C++ and integrate the system directly into shooting code so the beam is triggered instantly when firing. Welcome to the Game Creator Accelerator channel. I am Tony Munoz. Make sure to like the video, subscribe, comment, share it, and ring the bell so you don't miss future Unreal Engine and C++ tutorials focused on real production workflows. This video is part of a game named Mad Gameverse, a third-person shooter I am building completely from scratch. You have full access to the process, the design, decisions, and the actual Unreal Engine C++ code used to build the game. Access the playlist in the description. And don't forget to visit woolen.com to learn more about my mentorship program and how to build your path as a game developer even after office hours. If you are balancing work, life, and responsibilities and feel stuck trying to break into or grow in the gaming industry, this might be the structure and guidance you are looking for. Now, let's get started. Let's start checking out what we have so far. So far, we created a line trace, and as you can see, we have also a debug for this line trace. But I'm not going to use the debug. I need to use a beam that is created at the moment of the shooting. The first step is to put some things in order. So I'm going to Games, Assets, Niagara, and let's create a new folder that I will name NS Beam Trail. Open the folder, right-click and select Niagara System. Let's add a simple sprite burst. This option and create. And rename it NS for Niagara System Bullet Beam. Now open the new Niagara System and let's remove some elements. First, I'm going to remove the sprite renderer, the solve forces and velocity, delete. And now in the section of the renderer, I'm going to add one special name, Ribbon Renderer. Select this one. This is one of the key elements that we need to create the beam that we want. Having selected the Ribbon Renderer, check that you have in the facing mode screen and the max number of ribbons will be 1. That will represent the ribbon or the beam for the bullet that you shoot. And because we're going to shoot one bullet at a time, I just need at this point 1 ribbon. Now select the initialize particle and in the ribbon attributes, select the ribbon width mode and click and select direct sect. And for this case, I'm going to set it to 2. And in the section where it says lifetime, let's set it to 0.08. It could be something between 0.05 and 0.09. I think that 0.08 is going to work perfectly. Finally, let's talk about the position mode. Click on this arrow to select direct sect and leave the position as it is. And to make some small change, I will also add a color to make it more visual. And let's do something like an orange. The next step to create the beam is to define where it's going to start and where it's going to end. For that, to the left, we're going to establish some user parameters. Because the positions are related to vectors, that is the type that we will use. So click the plus, look for vector, pick vector, and for the beginning, let's call it start, and repeat the process. Again, look for vector, and for the end, we're going to use target. To visualize these two elements, I'm going to separate them a bit. This will be only to visualize it in this section, in the preview. So I'm going to set the value of x in, let's say, 500. Back to the simple sprite burst. Let's set these parameters now. In the particle spawn, click on the plus and look for set and pick the set new or existing parameter directly. To the right, click on the plus and look for position. Select the one related to core parameters particle position. Now, inside the particle positions engine emitter, you have an arrow. Click this arrow and look for make custom position from boolean and select it. Just to visualize more clear these elements, for a second I'm going to remove this particle state and go back to the particle position. Now in details, besides the bool you have an arrow. Click this arrow and look for set bool by float comparison. Click it. Now let's set these two parameters. Click on the arrow on the A and look for return normalize exact index. And for B, we're going to set the value of 0.5. And in the comparison type, select A less than B, this one. Let's explain this a little bit. The set bool by float comparison is simply a decision maker. It takes two values of A and B and compares them using a rule. And that returns either true or false. In our case, A comes from return normalized exact index, which gives each particle a clean value between 0 and 1 based on the order Niagara's processed them. Since we spawn exactly two particles for the beam, one will get the value close to 0.0 and the other value close to 1.0. That already gives us a reliable way to tell them apart. We set the value of B to 0.5 because it sits right in the middle of that normalized range. This let us split the particles into two clear groups. Then, with the comparison type set to A less than B, we are saying if this particle's normalized index is less than 0.5, treat it as the first particle. Otherwise, treat it as the second one. In practical terms, this means one particle is consistently assigned to the start position, which is this one, and the other assigned to the target position. The reason we use return normalized exact index instead of raw particles ID is stability and simplicity. Raw indices can be unpredictable or harder to reason about, while a normalized value guarantees a clean 0 to 1 range every time. Combined with set bool by float comparison, this gives us a very readable and reliable way to decide which particle represents the beginning of the beam and which one represents the end. This is what allows the ribbon to stretch correctly from the muzzle to the hit point every single shot. Now we can set the values of true position and false position. For the true position, click on the arrow and select Convert Vector to Position, this option. Now in the input position, click on this arrow and select User and pick the option User Start. Let's do something similar for the false position. Click on the arrow, Convert, select Convert Vector to Position, click the input position arrow, look for User, but in this case will be the target. So for the true will be this position, and for the false will be the target position. We're going very well. Always confirm that in the initialized particle, you have the lifetime around 0.08 and the ribbon 2.0. If you click the spawn burst instantaneous, you can see that we have only one particle. That is why we can't see the beam yet. We need two particles that represents the start and the target. So update the spawn count to 2. And now you can start visualizing the beam on the preview. Here is our line. It's small, but here it is. Another small change that we'll do is in the NS bullet beam, click on Properties, select the fixed bound, and in the mean value, set something like -6000 for every parameter, X, Y, and Z, and for the max, 6000, 6000, 6000. I'm sorry, for the minimum was -6000, -6000, and -6000. This prevents sometimes it shows, sometimes it doesn't, because the beam can be outside out of bounds of one frame. Now let's go to the emitter state. Confirm that you have this option of inactive response, complete let particle finish, then kill emitter. The loop behavior has to be once, and the loop duration we're going to establish to 0.05, a little bit less than the duration of the particle. Now in particle update, click the plus and look for particle state. Select the particle state and confirm that you have checked the kill particle when lifetime has elapsed. Finally compile and save. And with this, we've finished the part of creating the beam using the new Niagara system. I want to let you know that this channel is part of a bigger journey called the Game Creator Accelerator Lifetime Mentorship. It is built specifically for someone with limited time who needs direct guidance to build a solid path in the gaming industry. The goal is a measurable transformation into a game creator, not just watching tutorials, not just collecting notes or certifications, but building proof through learning technical skills with direction, creating projects to develop the skills, and using proven strategies and methodologies to set up a brand for yourself and your creations. You and I work together to build your Unreal Engine games, learn core principles and how to solve challenges, and grow your social media presence to share your work with studios, publishers, recruiters, and players. This is the same approach successful indie creators use, myself included. But unlike me, you don't have to learn it the hard way. Today, learning in isolation, submitting applications, or developing without leaving a mark doesn't work. You grow by creating, sharing, and making opportunities come to you, not chasing them backwards. The GCA mentorship will help you transition to the work of your dreams without jeopardizing your current circumstances. If you want to learn more, visit woolun.com and schedule a one-on-one chat with me. The link is in the description. Now let's call this Niagara system. So I'll go to my shooter Oasis and open the shooter character. First, we need access to the new Niagara system that we created. So in the shooter character header, this will be a T object pointer U Niagara system, and I named this bullet. Let's pick this by default, but I'm going to make a quick change. Instead of trace, I'm going to call it beam. For the U property, I like this one, so I'm going to pick it and finish here with axis equals true. And then, of course, let's add a description that will be bullet beam Niagara system and save. Now let's go to the implementation and look for the shoot button pressed. This is the method that I will call when I'm shooting the weapon. If you want to check all the details of this method, you can check the previous lessons related to the creation of this video game. Link to the entire playlist is in the description. Now I'm going to make some changes to this function because I want to make it more efficient, and then I will add the call to the Niagara system. First, I don't need this section, so I can remove it. I don't need the U lock. The shoot sound is okay because I have to confirm if I have a shoot sound before playing that sound. The next line is to confirm if I set a muzzle flash Niagara. So this is the effect of the explosion in the muzzle of the weapon, and you can leave it like as it is. Now the next section is where the big changes happen, which is this if, where I'm checking the skeletal mesh socket. The first change I will do is that I will define this as a parameter, but outside the if. So I'm going to copy this section and leave it here on the top, and then I will say if not barrel socket, then return. Inside the if, you see that we have a line trace single by channel that I don't need any longer. And then we have the hit result, and inside the hit result we have the draw bug line and draw bug point. Those things I don't need it neither. So I'm going to take the entire section of this if, and I will remove it. Just to remembering some things, keep in mind that we set the barrel socket for the raid skeleton, which is our character, and it is here on the muzzle of the weapon. And this is the one we're extracting and assigning to this variable. Now let's get more information. The first one will be the const transform for the socket transform. The barrel socket, get socket transform, and get mesh. Great suggestion, by the way. The next one will be a f vector to define where the socket start. I'm going to name it start, just start. And another const and f vector to identify where the socket ends. I can take this default, and in this case I'm going to call it trace end. Yeah, let me change the value here to trace start. And here will be as well trace start. More clear. So remember that I told you to check this here. I'm going to remove it, and after this trace end, I will check if muzzle flash Niagara, then I'm going to spawn on this location. Let me check that all parameters are exactly what I want. Socket transform get location, and socket transform get rotation rotator. Excellent. Now for the trace, I want to do something. I want trace, but I want to ignore self because this is recommended in this case. The first element is that I need is the f hit result. Then I'm going to set the parameters for f collision query params that I will set to params, and the values will be first scene query start shoot trace, and the second parameter will be true, and then params dot at ignore actor this. Let's quickly remember some concepts in Unreal. The hit result, this is just an Unreal container that we use to store the result of a trace. If the trace hits something, this structure will hold information like what was hit, where it was hit, and the surface normal at that point. Then we have the F collision query params. This controls how the line trace behaves. The scene query start shoot trace is mainly for debugging and profiling. It gives these trace a readable name so Unreal can track it internally. The true parameter enables more accurate collision checks, which is usually what you want for weapon traces. Finally, we have the at ignore actor this, and this is a critical element. This tells the trace to ignore the character that is firing the weapon. Without this, the line trace could immediately collide with the shooter on capsule or mesh, causing false hit. By ignoring this, we ensure that the trace only checks the world and valid targets in front of the weapon. In short, these lines prepare a clean, reliable trace setup so the shot can detect real targets without accidentally hitting the player who fired it. Now let's add another const, which will be a boolean for be hit, where we're going to check in the world using the line trace single by channel, the information of the hit result, the trace start, the trace end, and the visibility parameters. And another const for f vector, I will call it end, which will be hit, and we are asking if hit is true, then the end vector will be the trace end of the hit result location. Now it's time to spawn the beam. Let me make a comment, spawn beam instant tracer. If bullet beam in Niagara, this is the parameter we set just a moment ago in the header. Let's take, let me check this. Now I'm going to remove this line because I want to explain something in more detail. I'm just going to confirm that we have the bullet beam in Niagara. And now this is more the suggestion that I want. First, we are going to create the beam. In fact, I'm going to rename it beam component. So let me call it like beam comp and name it here and here. Because at the end, this is a Niagara component. We're using the uNiagara function library, spawn system add location, and setting the parameters that we need. First, the world, then the bullet beam Niagara that we created in Unreal, where the traces start, and the rotator. But in this case, I'm not going to use the F rotator. I'm going to use the socket transform rotator. Then by default, it suggests the beam component for set vector parameter for the end, name target. This is okay, but we are missing another, which is the start. So beam component set vector param to start, which will be the start trace. And now I'm going to add other effects related to impact, BFX, plus a decal only if we hit something. So if B hit, then we check if impact Niagara and if impact decal materials, which are two parameters that I defined previously. In fact, this one is not impact decal material, is impact decal mat. And I have to change it as well here. You can check the previous lessons where I explained how this worked, but it is pretty straightforward. The impact Niagara, what we do is that we spawn at a specific location in the get world. We spawn the impact Niagara, and we have other two parameters, which are the location, which is where the hit happens, and the rotation based on the hit. For the impact decal mat, I'm going to make just one extra thing, which is I'm going to add an F vector. Let's call it N, which will be the hit result impact normal, get save normal. And then in the parameters, let me check them in order, will be impact decal mat. In this case, I have another parameter, which is the impact decal size. The hit result impact point is going to be changed by hit result dot impact point plus n, which is this value. And for the impact rotation, I will use minus n dot rotation. I forgot the parentheses, and this value will be 20. Perfect. Let's put it all in just one line. And the last part is related to animation that I won't cover today. So save. And let's compile in Unreal. Compile perfect. Let's open the shooter-based character, because now we need to set the new parameter that we created. Name bullet beam Niagara. Here we have it. And the value we are assigned is the NS bullet beam. So look for NS bullet beam, compile and save. Now let's test it. Here's our character, and there you can see. You can see the beam of the shooting, which create a fantastic effect. I just realized that the smoke of the impact is not working, so let's go back to the shooter-based character. Look for Niagara, and here is the impact Niagara that is not working, and that is the NS smoke dust. Compile, save. Now we should have all elements working together. Excellent. So we have, let me see it against the wall. Oh, it's looking fantastic. Love it. Today we built a fast visual beam system for a shooter in Unreal Engine 5.7. We created a ribbon-based beam in Niagara to show bullet direction instantly, even though the shot itself is still a line trace hitscan. Then we integrated it in C++ so it triggers the moment we fire, using the muzzle as the start and the hit location as the target. This is a small system, but it's a great example of how visuals, code, and design come together to improve responsiveness and player perception in a shooter. In other words, immersion. To support this channel, make sure to like the video, subscribe, leave a comment, share it with your community, and ring the bell so you don't miss future Unreal Engine and C++ tutorials. And if you want guidance beyond individual tutorials, visit woolen.com to learn more about my mentorship program and how to build a real path as a game developer even after office hours. If you are balancing work, life, and responsibilities and feel stuck, this program is designed to help you move forward with clarity and structure. And until next time, keep creating, keep sharing, and most importantly, keep dreaming big. I'll see you soon, my fellow creators.